So 14.7 is solving equations using the zero product rule. So we learned how to factor in all these different cases and all these different ways. Now we're going to take that method of factoring and actually use it to solve these equations, okay? So the only difference we're going to see now is we're going to see our standard form of ax squared plus bx plus c, and it's going to have it equal to 0 because we are now solving for our x value. So the concepts we're going to look through are the definition of a quadratic equation, the zero product rule, so the definition of that, and then solving equations by factoring. So all we did so far has just been factoring. Now we're solving them. So concept 1, the definition of a quadratic equation, is that formula right here, that ax squared plus bx plus c equals 0. Okay, that is a quadratic equation, so we're moving away from linear and we are going into quadratic. Concept 2, the zero product rule. The zero product rule states that if a times b equals 0, then that tells us that either a is 0 or b is 0, which makes sense, right? If you had two numbers that multiply to 0, one of those numbers have to be 0, okay? In this case, the a and the b are going to be our parentheses. So a will be the first parenthesis, b will be the second parenthesis. Okay? So this is looking at our concept of a times b equals 0. Okay? And we are labeling the first parenthesis as a and the second parenthesis as b. So this is telling us that if this equals 0, that means that either of these parentheses have to equal 0. So we're going to set them separately equal to 0. So x minus 4 equals 0 and x plus 3 equals 0. Because notice, we already have an answer that is factored for us. So once I set them each separately equal to 0, I'm going to be solving for x. So on the first one, to solve for x, I'm going to add 4 to both sides. And I get x equals 4. And for the second one, I'm going to subtract 3 from both sides, and I get x equals 3. Negative 3. Yes. Well, thank you. Negative 3. Meaning that these are my two possible answers for this equation. My answer could possibly be 4, or it could be negative 3. And just like all the problems, we could check our work. And the way that we check our work is plugging in these x values one at a time. So I'm first going to plug in 4. So I have 4 minus 4 and 4 plus 3. So wherever there was an x, I plugged in a 4. So now I am solving this to see if I get 0. 4 minus 4 is 0. 4 plus 3 is 7. 0 times 0 is 0. So 0 equals 0 tells us this is true. And I can check for my other x value. So now I'm plugging in negative 3 for x. So negative 3 minus 4 and negative 3 plus 3 equals 0. Negative 3 and negative 4 gives me negative 7. Negative 3 and positive 3 gives me 0. Negative 7 and 0 is 0. 0 equals 0 is a true statement. So again, this was just a way to check your work. These are your answers up here. Any questions on number 1? Okay, so for number 2, we're going to do the same thing. We're setting each parenthesis equal to 0 separately, and we're going to get our answer. So you don't need to check your work unless you feel like you need to check your work. So that means I have x plus 1 equals 0, x minus 8 equals 0. Once I have them both set equal to 0, I solve. So in the first one, I would subtract 1, and I get x equals negative 1. The next one, I would add 8, and I get x is equal to 8. And those are my answers. X equals negative 1, and x equals 8. Notice since we don't have any numbers in front of our x value, when we're looking at our answers, when setting it to 0, all that's happening is that those numbers after x are just swapping signs. Okay? That's only the case when we don't have a number in front of x. Okay, go ahead and work on number 3. You're setting them each equal to 0. In this case, we do have a parenthesis that has a 4 in front of x. So it's going to be one additional step. Okay, so you should have set x plus 8 equal to 0 and 4x plus 1 equal to 0. Solving the first one, we would subtract 8 from both sides, and we get x is equal to negative 8. And for the second one, we have 2 things that we need to do to get x by itself. So first, we would subtract 1, and we would get 4x equals negative 1. Then divide by 4, so we get x is equal to negative 1/4. Now I'm going to go ahead and just leave my answers as fractions. Okay. The only reason we would change it into a decimal if it was ever asking you to graph. So looking at these first 3 examples that we did, can anyone tell me what we're ultimately finding? So yes, we are solving for x, but in terms of a quadratic function, what are we finding?
Where y equals 0.
Yes, and what is that called?
The y-x-intercept.
The x-intercepts. So that's what we're finding, the x-intercepts. And notice that each of them have 2 x-intercepts, because if we were to just draw the simple graph of a quadratic, it's all, okay, not all, most times it's going to cross twice at the x-axis. So what we're finding here when we solve are these x-intercepts. Okay, so just keep that in mind for future. Okay, go ahead and work on number 4. Same thing, setting each separately equal to 0. Remember to keep your answer as a fraction. Okay, so setting them both equal to 0, let's solve the first one. So I would first add 5 to both sides, and I get 4x is equal to 5. then divide both sides by 4, and I get x is equal to 5/4. So that should have been your first answer. And then in the second one, we would subtract 6 to both sides, and we get x is equal to -6. So that's your second answer. So 5/4 and -6. Okay, now on number 5, we have something that looks a little different. We don't have those two parentheses next to each other. However, we still have our A and B term. So in this case, our A term is just going to be what? X. So this is our A term, this is our B term, and we know that A times B equals 0. So we're still setting the A term and the B term equal to 0. So in this case, since x is our A term, we would just write x equals 0. And that's right away our first answer. X equals 0. Then we would take our second term, that parentheses, 3x minus 7, and set it equal to 0. And then in order to do that, we have to add 7 to both sides, and we get 3x is equal to 7. Divide by 3, x is equal to 7/3. Okay, so here we still have two answers, even though we didn't have two specific parentheses. Okay. And this concept would only work since our A value was a variable. If that A value was a number, we couldn't say number equals 0, especially if that number was like, say, 5. 5 equals 0. That doesn't make sense. Okay? In those cases, that tells us that there's only going to be one answer, one x. Okay, so this has to be a variable. Okay, go ahead and try number 6. So number 6, exactly like number 5, setting both the A and B term equal to 0. So for this one, you should have got x equals 0, because we set that first term equal to 0, so that gives us our first answer. And then 4x plus 9 equals 0. We would have to subtract the 9 from both sides. And we get 4x equals -9. Divide by 4, and we get x is equal to -9/4. So those are the two answers you should have got, 0 and -9/4. Okay, so now that we learned that zero product property of setting each part equal to 0, we're going to use that and the skills that we learned from factoring, and we're going to put it all into one problem. Okay. So for example, on number 7, we now have something that needs to be factored, and then once we factor it, we can set those factors equal to 0. Just remember that our standard form is that ax squared plus bx plus c equals 0. So we cannot start solving until we have our problem equal to 0. So in number 7, what do we have to do first? move the 5 over. So I'm going to subtract 5 over, and I get 2x squared minus 9x minus 5 equals 0. So that minus 5 just got attached to the end, and it is our C value. Okay. Now that we have everything in the correct order, we're going to use whatever method we learned so far to factor. So whatever method you find easier, that's the method you would use. On the notes, I'm just going to be using factor by grouping. Okay. So for factor by grouping, I know I have to multiply my a times my c. So a times c is 2 times negative 5, which is negative 10. And my b value is negative 9. So this tells me I need two numbers that multiply to negative 10, but add to negative 9. Any idea what those numbers would be? 1 and negative 10. Good. So 1 times negative 10. If I add that together, it gives me negative 9. So these are my factors, 1 and negative 10. So I have 2x squared plus x minus 10x minus 5 equals 0. So I took my b value of negative 9x and expanded it into my factors. That gave me 4 terms, which tells me I do factor by grouping. So I'm going to take the GCF out of the first term, and that GCF is x. So I'm left with 2x plus 1. And then the GCF out of the second term is negative 5, and I'm left with 2x plus 1. So that means my factors for this problem is x minus 5 and 2x plus 1. But since my problem is equal to 0, I don't stop here anymore. I have to find my answer. I have to find x. So I'm going to set each of these factors equal to 0, and I'm going to find both my answers. So x minus 5 equals 0, and 2x plus 1 equals 0. The first one I add 5 over, and I get x equals 5. And then the last one I subtract 1, and then divide by 2, and I get x is equal to negative 1/2. Okay, so all this in the beginning we already learned. What we're doing in these notes is just attaching this new concept we just learned. So we're solving. On an exam, it will tell you if you're solving, or it will tell you if you're just factoring, okay? If it says solve, then you know you have to get all the way to the end to find x. If it says just a factor, then you would stop here at just the factors. So factoring versus solving. Okay, number 8. Remember the first thing we check to see if it's in standard form. Is it in standard form? No. What do we need to do to make it standard form? Move the 24 over. So I'm going to add that 24 to the other side. That way I have it equal to 0. So I have 2y squared plus 19y plus 24 equals 0. Okay. Then once I have this, I always check if I can take out a GCF. Can I from 2, 19, and 24? No, I can't. So then I just continue on doing my factor by grouping. So I do my a times c. So a times c is 2 times 24, which is 48, and my b value is 19. So two numbers that multiply to 48 but add to to 19? Any guesses on that? 3 and 16? Good, and both positive. So 3 times 16. Because 3 times 16 gives us a positive 48. And if we were to add that, 3 plus 16 gives us that positive 19. So we have the terms 3 and 16. So expanding my problem, I now have 2y squared plus 3y plus 16y plus 24 equals 0. These 4 terms tell me I'm factoring by grouping. And I need to take the GCF out of each parenthesis. So my GCF out of my first one would just be y, because I can't take out a GCF from 2 and 3. So just y. And I'm left with 2y plus 3. And then from 16y plus 24, I can take out an 8. And I'm left with 2y plus 3. Remember, I want those parentheses to be exactly the same. So that leaves me with the factors of y plus 8 and 2y plus 3 is equal to 0. But since I have my factors equal to 0, I need to solve by setting them each equal to 0. So I can solve for y. So that means in my first one, I would subtract 8 over, and I get y equals negative 8. And in my second one, I would have to subtract 3, and I get 2y equals negative 3. Divide by 2, I get y is equal to negative 3 over 2. So those are my answers. So it's taking everything that we've learned in this unit so far, putting it all together to actually be able to solve this final concept. And that was this, being able to factor and solve quadratic equations. Any questions? Okay. Now we have a problem like number 9. What do you notice is different about number 9?
It doesn't have a C value?
Good, it doesn't have a C value. However, is this in standard form? Yes, because it is equal to 0. So it's just missing that C value. So right away that tells us instead of going into that factor by grouping, because we don't have anything to multiply A times C, we can first see if we can take out a GCF. Can we take out a GCF? 4x. So GCF is equal to 4x. If I take out a 4x, I'm left with what?
X plus 6.
X plus 6. Okay. Now this is completely factored. It's completely factored. And we're still able to use that product rule of A times B equals 0. So what is going to be the first term we set equal to 0? 4x. So 4x equals 0, and then x plus 6 equals 0. So we're still going to have 2 answers here. This one was just a little easier because we didn't have to do any excessive factoring. So for the first one, we would divide by 4, and we get x equals 0, because 0 divided by anything is 0. And then in the next one, we would subtract 6, and we get x is equal to negative 6. Those are our answers. So we still had to factor, but we didn't have to go through the large steps of factor by grouping, okay? What about number 10? First, is it in standard form? Is it equal to 0?
No.
No, so what would we have to do to make it equal to 0?
Move the 45 over.
Move the 45. So 5s squared minus 45 equals 0. So now instead of missing the c term, it's missing which?
The D term.
The b term. Does this look similar to a problem we solved today?
Perfect square after its factor.
Good. It looks like something that could have that perfect square, but we can take a GCF out of that. And what would the GCF be?
5.
Good. So if we take the GCF of 5 out, we're left with s squared minus 9 equals 0. Now does that middle term look like a perfect square? So that means we take the square root of each term, and we get s and 3. Okay. So that means just from the parentheses, what is my factors here?
S plus 3, S minus 3.
Good. S plus 3, s minus 3. And I bring down that 5, set it equal to 0. Okay. Now that everything's factored, I have to solve. So remember, I set every single part equal to 0. So in this case, including that 5, I'm going to set that 5 equal to 0. 5 equals 0. Is that true? No, it's not a true statement, so I ignore it. Then I go to s plus 3 equals 0. Solve that one, and I get s equals negative 3. And then I do s minus 3 equals 0. Solve that one, and I get s equals 3. I need to see this step. Even though 5 equals 0 is a false statement, I still need to see that you understand that every component has to be set equal to 0. Okay. So again, this is not an answer because it's a false statement. So that means we only had two answers here, negative 3 and positive 3. Okay, let's look at the next one. Okay, so in number 11, this definitely does not look like standard form whatsoever. Okay, so our first step is to get this into standard form. So what would we do first in order to get this to look like the ax squared plus bx plus c equals 0? Good. I could FOIL the 5x first, or distribute because it's just one term being multiplied in. So that would be 25x squared plus 10x is equal to 10x plus 9. Because I just rewrote my whole problem after I distributed. What would be my next step to make it look like my standard form?
Move the 10x.
Good, I'm going to move the 10x over. Notice that that cancels out the other side because I have a positive 10x and a negative 10x. So I'm left with 25x squared equals 9. What would be my next step? Move over the 9. So I have 25x squared minus 9 equals 0. So now it's in that standard form because we have it equal to 0. But this is going to be what type of problem to determine like which factoring method we're using.
Is it the perfect square?
Perfect square. So we can take the square root of each one of these. So that tells us that it is a perfect square trinomial. So the square root of 25 is 5. Square root of x squared is x. Square root of 9 is 3, meaning I have the two factors of what? 5x plus 3 and minus 3 equals 0. Okay, so I got my factors. Now I have to set each one equal to 0 to get my answer. So 5x plus 3 equals 0, 5x minus 3 equals 0. On the first one, I would have to subtract 3, and I get 5x equals negative 3. Then divide each side by 5, and I get x is equal to negative 3/5. That's my first answer. On my next answer, I would have to add 3 to both sides, and I get 5x equals positive 3. Divide both sides by 5, I get x is equal to positive 3/5. So this is definitely the most important step in the beginning, is to make sure your equation is in standard form.
On something like this, for the sake of showing work, like in the beginning when you were moving everything over to the left side, do you want like the subtraction of 10x and the positive 9 done on separate lines, like actually in their own step, or can we do them at the same time?
You could do it at the same time. Yeah, you could have just moved the 9 over here, and I still see that what you're doing, so it's still counted in your work.
Okay.
For the purpose of notes, I just separate everything.
Gotcha.
Okay, number 12. So very similar to a number 11, we have to first get it into that standard form. So what would we do first? Distribute. So I have 4z squared plus 12z is equal to 4z plus 5. So I rewrote the entire problem once I distributed the 4z. Now what would I do?
Move the right side to the left.
Good, I need to move everything that's on that right side over to the left because I want it equal to 0. Okay, so I can subtract 4z and subtract 5. So that gives me 4z squared. And then I have a 12z minus a 4z, so that's an 8z. And then that minus 5. So now that I have everything in standard form, it looks like a typical quadratic problem that I'm going to have to factor by grouping. So before I start the factor by grouping, I always check if I can take out a GCF just to see if my numbers can reduce any. Is there a GCF for this one?
No.
No. So I'm just going to go on and just do my A times C and find my factors. So in this case, A times C is 4 times negative 5, which is negative 20. And my B value is 8. So I need two numbers that multiply to negative 20 but add to 8.
2 times, negative.
Negative 2 and
Good, negative 2 and 10. So negative 2 times 10, if I add those together, gives me a positive 8. So I'm using the factors of negative 2 and positive 10. So I have 4z squared minus 2z plus 10z minus 5 equals 0. So once I expanded that middle term, I'm doing my factor by grouping. And I'm taking out the GCF from each term. So I have 2z from the first one, and that leaves me with 2z minus 1. And from 10z minus 5, I can take out a 5, and I'm left with 2z minus 1. So that means my factors are 2z plus 5, and 2z minus 1 is equal to 0. Now I set each equal to 0 to get my answer. So 2z plus 5 equals 0, and 2z minus 1 equals 0. So from the first term, I'm going to subtract 5, and I get 2z equals negative 5. And then I'm going to divide by 2, and I get z is equal to negative 5 halves. For the second part, I'm going to add 1 to both sides, and I get 2z is equal to 1. Then I'm going to divide both sides by 2, and I get z is equal to 1/2. So I have my answers of negative 5 halves and positive 1/2. Any questions so far? Okay. So now on number 13, notice that even though this is not in standard form, because it's not written as that ax squared plus bx plus c, we notice from here that our equation is already factored because of all these parentheses here. Okay, it's already factored for us. So since it's already factored for us and it's already equal to 0, what can we do to each of these terms? Set them equal to 0. Okay. Remember, in order for showing my work purposes, I still am going to set that negative 6 equal to 0, even though it's false. So negative 6 equals 0. That's a false statement, so I ignore it. And then I do y plus 3 equals 0, which if I subtract 3 over, gives me y equals negative 3. Then I go on to the next parentheses. Y minus 5 equals 0. Add 5 to both sides. That gives me y equals 5. And then the last parenthesis, 2y plus 7 equals 0. I'm going to subtract 7, and I get 2y is equal to negative 7. Divide by 2. Y is equal to negative 7 halves. So in the case of number 13, we didn't have to factor it because it already gave us our answer in terms of factors. Okay. And I knew that because of all the separate parentheses that are being multiplied together and that my equation was already equal to 0. Go ahead and work on 14. 14, same concept as 13. Okay, as you're working on the problem, I'm gonna go ahead and start setting it up. So I'm setting everything equal to 0. Okay. Once I have everything set equal to 0, I'm going to go ahead and go through it. So that 5 equals 0, that is a false statement, so I ignore it. P plus 4 equal to 0. I'm going to add 4 over, and I get P is equal to 4. p plus 7 equals 0. I'm going to subtract the 7 over, and I get p equals negative 7. And for 2p minus 9 equals 0, I'm going to add the 9 over, and I get 2p equals 9. Then I'm going to divide both sides by 2, and I get p is equal to 9/2. So you should have got the answers 4, negative 7, and 9/2. Number 15, we have a problem already equal to 0, so that's a good start. However, instead of our 3 terms, we have 4 terms. So right away that should tell you to do what?
Factor by grouping.
Factor by grouping. Factor by grouping, I'm going to take the GCF from the first parenthesis, and that GCF is going to be w squared. So I'm left with w plus 5. And from the next parenthesis, I'm going to take out a negative 9, and I'm left with w plus 5, okay, equals 0. I'm then left with the factors w squared minus 9 and w plus 5 equals 0. Am I able to simplify more?
Yes.
Yes, what tells you that?
That's the w squared.
The w squared. That w squared in the first parentheses tells you that most likely we can simplify this further. Since this w squared minus 9 is a perfect square, we're going to take the square root of each term to be able to separate this into a smaller factor. So the square root of w squared is w, square root of 9 is 3. So I'm going to have the factors w plus 3, w minus 3, and w plus 5 equals 0. Now looking at all of my factors, it looks like everything is as factored as it can get. It's as simplified as possible. So then I'm going to set all the parentheses equal to 0. So w plus 3 equals 0, w minus 3 equals 0, and w plus 5 equals 0. That's going to give me the answer w equals negative 3, w equals 3, and w equals negative 5. And just like we did on number 1, if you, for whatever reason, want to check your work, you could plug in each of these w's in separately, and you should always get the answer of 0. Okay, go ahead and take a moment and work on 16. We have 4 terms, so that should tell you to do what? Factor by grouping. Okay, so for factor by grouping, you should separate your first 2 terms and your last 2 terms. Take the GCF of the first term, which we would take out an x squared, and be left with x plus 3. And from the next parentheses, I'm going to take out a negative 4, so I have a matching x plus 3. This leaves me with x squared minus 4 and x plus 3 equals 0. I see that x squared in my first parentheses, so that tells me I need to factor more. So in order to do that, I see that the first and last term are perfect squares. So I can take the square root of x squared and get x, square root of 4 and get 2. So I have my factors x plus 2, x minus 2, x plus 3 equals 0. Once I have this completely factored, I set each term equal to 0. So I have x plus 2 equals 0, x minus 2 equals 0, and x plus 3 equals 0. And solving each equation for x, you should have got x is equal to negative 2, x is equal to positive 2, and x is equal to negative 3. And that concludes these notes. Let me look at this. Okay. So let's